Hi, I'm Matt, and I'm here with Rishi to describe our product, the Symfuny. According to a 2014 study conducted by the Center of Disease Control and Prevention, 1 in 68 people are born with autism. This represents a 30% increase from the same estimate made in 2012 and a massive 600% increase in autism prevalence over the past 2 decades. Disorders on the autism spectrum inhibit social growth and development. Because of this, many affected individuals have trouble expressing themselves through words and conversation. This leaves art as one of the few remaining viable forms of self-expression. Our device, called the Symfuny, is a therapeutic product that incorporates both music and dance. This product is intended for dance movement therapists to help autistic individuals with self-expression. The function of the Symfuny is to produce music to bring an individual to a desired mood. The songs will be uploaded from one's computer and will change based on the current and desired mood of the user, as well as their activity level, as measured by the amount of movement recorded by the accelerometer. For example, if the child is overly excited and wants to become more relaxed, the songs will start out faster and gradually decrease in tempo as they begin to dance slower and become more relaxed. Conversely, if they are sad and want to become more excited, the songs will start with a slower tempo to match the current mood and gradually increase the tempo as they begin to dance faster, thus making them more excited and expressive. There's also a pulse sensor on the device, which would allow the therapist to monitor and track the individual's pulse over time. One of the only comparable products on the market is the Skoog. The Skoog is a cube-shaped device that allows children with disabilities to interact with music in an expressive way. Its primary market is special needs education and music therapy, targeted at those unable to play conventional musical instruments. However, the Symfuny is superior to the Skoog because the Symfuny encourages movement and offers more complex features such as the mood modulation software and the heart rate detection.
Our product uses 2 different Arduinos for different functions. We also implemented additional components to interact with the Arduinos. One of the Arduinos is attached to an Adafruit music shield that's configured to play different songs that are previously downloaded onto an SD card. We also used a BN055 accelerometer from Adafruit in order to interpret the user's movement of Symfuny. Finally, we added a pulsometer to a second Arduino. The pulsometer is used with an additional monitor to display heart rate and pulse readings for a therapist that may be working with someone who is autistic. We first reconfigured the accelerometer code to output raw data. From this, we were able to extract linear acceleration in each axis from the accelerometer. Encoding the interactions between the accelerometer and music shield, we used conditional statements based on acceleration to output different 15-second sound clips. We decided to use acceleration changes in the y direction, and in order to make clean transitions, we normalized the acceleration vector to cover a range of integer values that were set as variable I. The conditional statements were coded such that the slower accelerations of the device played slower songs and vice versa. We also used the second Arduino to output pulsometer readings onto a program called processing. In the following demonstration, the child may be starting out in a relaxed or possibly sad mood and is trying to become more excited with faster movements to faster songs. Notice how the pulse readings on the screen increase as the subject moves and dances more. Overall, we're very pleased with how Symfuny performs. As autism prevalence continues to exponentially increase every year, the need for a safe and fun autism therapy device becomes greater. Some of the advantages of our device is that it's relatively lightweight, easy to be used, and customizable with different music that changes based on the user's mood. Our prototype also has some limitations. Eventually, we would like to use small microcontrollers to compress it into a stick-shaped housing, as well as include batteries to eliminate all cords. There are also a limited number of songs that the Arduino can currently process. We hope that future models would be able to incorporate these changes.